Could international superstar and sprinter Usain Bolt beat a dinosaur in a race? That in a report at Study Finds, where we invite you to like and subscribe for the latest information. I know what you're saying. Why? Well, Professor Scott Lee, a physics professor at the University of Toledo, explains that creating an outlandish scenario like man versus dinosaur is a great way to spark students' imagination and overall class engagement. I get it. That's like the does one drop of water raise the level of the entire ocean kind of thing. Well, it does, you know. Anyway, so how would Usain Bolt fare in a race against a 900-pound dinosaur called the Dilophosaurus? Let's dive in, shall we? The physics students must employ a complex combination of displacement, velocity, speed, acceleration, all using spreadsheets to answer the riddle. Ultimately, the science largely suggests that Bolt would take advantage of Newton's second law of motion and his own acceleration to beat out the dinosaur by 2 seconds. Bam! Let's look at this chart. The acceleration measured in meters per second squared of Usain Bolt is on the left, clearly, and Dilophosaurus is on the right. In the 100-meter race, Mr. Bolt clearly kicks the dinosaur's ass. And now a trip down memory lane. Professor Lee credits his approach to teaching physics to discovering fossils with his family, then later on discovering what he called an approachable book on dinosaur motion physics with his daughter. Lee put together an entire general education course for non-science majors focusing on dinosaurs with that book in hand. So he's a cool teacher, and that is awesome. But I'm thinking this is a course for all the people with the football scholarships, right? I'm kidding, of course. Not sure where that awful stereotype comes from. Okay, back to the math problem. I'm sure you enjoyed that trip down memory lane, but students have to consider Newton's second law of motion, which states acceleration is determined by mass plus force. So Mr. Bolt's much smaller size would give the runner an early advantage. After agreeing on the hypothetical race's winner, students then discuss similar speed assessments and their implications regarding physics. For example, how a lioness uses her quick acceleration to catch and kill faster prey. Lee hopes these outside-of-the-box teaching tactics help more students get excited about physics, and that is also pretty cool. So check out more detail in the link in the description below on this and other studies at studyfinds.com.